Hello everyone, my name is Marcos and I will present our industrial study to improve bug localization by mining crash reports. Crash reports and stack traces are important to know what the user was doing when a crash occurred. Therefore, tools were developed to collect and process crash information. Previous works found that stack traces can help developers to fix bugs, and crash report grouping is useful to find and fix buggy code. A stack trace is an ordered set of frames where each frame refers to a method signature. The innermost method is called a crash point. Companies use mechanisms to report crash automatically. This generates a large volume of data with possible redundancy and repetition. To mitigate this problem, crash reports can be grouped based on similarity of stack traces and used by developers to facilitate bug identification and fixing. Federal University of Rio Grande do Norte has developed large-scale web systems that are used by many government and academic institutions in Brazil. They have reported the difficulty of using a large volume of crash reports during the bug fix tasks. So, we decided to investigate whether and to what extent information contained in crash reports can help developers locating bugs in proprietary web-based systems, since it was a limitation of previous works. In our approach, we process and group the crash reports by stack trace in 5 ordered and cumulative levels. Initially, we group crash reports whose stack traces are identical. Next, we group distinct groups whose signatures were almost identical. After that, we create the other 3 levels of grouping based on roles proposed by Rangi and colleagues. Crash type signature groups 2 sets A and B when all of A stack trace frames are present in the same order in B stack trace. Top frame file correlates to groups when they have the same qualified file name in the most inner frame of the call stack. Frequent closed ordered subsets take into account whether 2 groups of crash reports have at least one common frequent close sequence of frames. After grouping, we mine information of the files present in stack traces of the crash report groupings and use this information to rank the suspicious files. Our approach assigns height scores to files that appeared more often in the stack trace of a group, less frequently in stack trace in other groups, and closer to the crash point. For each of the ranked files, we identified the methods that appeared in stack trace of a respective group of crash reports and suggest them to developers, showing the most frequent ones first. We conducted a study to answer the 2 research questions. What is the performance of our stack trace approach to identify bug code files in Java web-based systems? To what extent do methods from the closed bug fix issues appear in the stack trace of the associated crash report group? We selected 3 large-scale web-based Java systems as the target systems of our study. They together have almost 18,000 classes, more than 3 million lines of code, and more than 1 million daily requests. So, what we did to answer the research question 1? We collected crash reports from Elasticsearch during 8 months and we clustered the crash reports using our approach. We queried the resolved bug fix issues from Redmine in the same period, collecting those that had some stack trace reported and Git merge request information. We link crash report groups to issues by similarity of stack traces. We ranked the suspicious files for each crash report group linked to a bug fix issue. Finally, we compared the ranked list of suspicious files with the list of committed files. For instance, we successfully identified buggy classes with recall varying from 61 to 77%. Considering the top 1, 3, 5, and 10 suspicious bug files identified and ranked by our approach when considering the application of role 1. Precision ranged from 47 to 63% in the same configuration. What we did to answer the research question 2. In collaboration with the development teams for each one of the identified files, we extracted the name of the methods that have been changed in the bug fix commits. After that, we checked whether those methods appeared on the list of suggest methods of our approach. Finally, we checked how many methods from each of the identified files were present on the stack traces of the respective crash report group. We found that in most cases, between 74 and 92%, one or two methods of all the methods, changed or not changed from a changed files, appear in the stack traces of the crash reports. We also found that about 80% of changed methods from the closed bug fix issues appeared in the related stack trace of the crash reports groups. The method changed to fix a bug is the most frequently found on stack traces of the crash report groups or as often as other methods. Concluding, our approach can indicate bug components and reduce the cognitive effort. We are conducting new studies to collect feedback from developers about our approach. Thank you for listening.